So good morning, all of you. Last day I have discussed about the IO mode control word and the IO mode operation of 8255 programmable peripheral interface. Okay, so one example has been discussed. So today the topic is based on the BSR mode, the another mode of 8255 PPI. So in this mode, BSR mode, what happened? It is connected only with the 8 bits of port C. So we have port A, port B, and port C in 8255 PPI. So port A and port B, port C, all these are used in IO mode operation. But in BSR mode, or it's called the bit set reset mode. BSR means bit set reset mode. So in BSR mode, only port C is available, and which can be set or reset by writing an appropriate control word in the control register. Now a control word with bit D7, if this bit is 0, that is recognized as a BSR control word, and it does not alter any previously transmitted control word with bit D7 equals to 1, and thus the IO operation of port A and port B, these are not affected by a BSR control word operation. Okay, so if this D7 bit is 0, then entire D0 to D6 will be changed, and the change in this way, that is individual bits of port C, individual bits of port C can be uh, used for applications such as an on off switch type. Okay, you can you can connect some switches over this port C bits, so that you can on and off a particular bit. Now so I'll explain one by one this bit format of BSR mode. So if you want to set a particular bit of port C, so a particular bit of port C means you have 8 bits in port C. PC0, that is one bit. Second bit is PC1, then PC2, PC3, PC4, PC5, PC6, PC7. So total 8 bits are available in port C. Now you can set or reset any bit of port C. You can set either PC0 bit of port C, or you can set PC2 bit of port C, or you can reset PC3 bit of port C. So you can set or reset a particular bit of port C in 8255 PPI using this format. Now this D0 bit, it refers that if it is 1, that means your port C bit will be in set operation. But if this bit is 0, that means it is in reset position. Okay, so for all the bits of port C will be reset. So if you want to set your set a particular bit, you have to write down this D0 bit 1, and if you want to access it using reset mode of the individual bit can be reset according to your requirement, then this bit should be 0. Okay, this bit should be 0. Now next 3 bits, which are D1, D2, D3, these 3 bits are actually used to select a particular bits of port C. Like if this D1 bit is 0, this one is 0, and D3 bit is 0. So 0, 0, 0, it refers the particular bit of port C, that means PC0. So if you want to set PC0 bit, then these 3 bits must be 0, 0, 0, and this one will be 1. Now next combination will be 0, 0, 1. So it will be selected for PC1 bit, then 0, 1, 0 for PC2, 0, 1, 1 for PC3, 1, 0, 0 for PC4, 1, 0, 1 for PC5, 1, 1, 0 for PC6, and 1, 1, 1 for PC7. So to select a particular bit of port C, you need to use these combinations. using these 3 bits, so that you can set or reset the particular bit according to your requirement. Next 3 bits are not used, so always assume these are 0 0 0. Okay, so these are in don't care logic. D4, D5, D6 bits are not used, so assume these are always 0 0 0. Okay. So here the problem is given as write a BSR control word subroutine to set bits PC7 and PC3 and reset them after 10 millisecond. Use this configuration so that you can find out the port addresses, port A, port B, port C, as well as the control word register addresses using this configuration, and assume that a delay subroutine is available, because first you need to set these 2 bits, then call a delay program, then after delay, when delay is over, and that delay should be 10 millisecond, so after 10 millisecond the required number of bits, same bits, can be reset. Okay, so what will be the first here, I have told you that to start any operation using 8255 PPI, you have to find out the control word for this configuration. Okay, so here this is the 8255 PPI, and assume here is your microprocessor, where 8 address lines are to be connected only. A0 line, A1 line, these 2 lines are coming from the microprocessor A0 and A1 line, these are connected in this way, and from A2 to A6, all these are, assume these are 0 0 0 0 0 0, and only A7 is 1. So if 0 is there, after inverting this will be 1. So initially all the inputs of this NAND gate is 1. So it is known to us that if all the inputs of a NAND gates are high, then the output will be low, and that low output should be connected to the chip select pin of this 8255 PPI, because you need to select this IC, select this chip before starting the data transfer. Okay, and 2 control signals are to be interfaced or connected with the 8255, both of them, microprocessor and 8255. So microprocessor IO read control signal is to be connected with the read bar control signal of this 8255 PPI, and IO write control signal will be connected to the write bar pin of this 8255 PPI. Then reset signal is there. Okay, so how what will be the address? So write down the in memory mapping technique, that is A0, A1, A2, A3, A4, A5, A6, A7. Okay, 8 address lines. Now one question is there, so why we need to use these 8 address lines only? Because we have to implement this configuration into IO mapped IO method. Okay, it is under IO mapped IO configuration. So IO mapped IO configuration, here the port address should be always 8-bit in size. Port address should be 8-bit in size, and if it was connected via memory mapped IO technique, then port addresses should be 16-bit in size, just we have used in the last day uh, example. Okay, so that was based on memory mapped IO. Now today's problem is based on the IO mapped IO. Okay, so that's why the 8-bit port address is to be considered, and you have to write down in this way: A0, A1, A2, A3 up to A7, 8 address lines. So we know that A0, A1, if both are 0 0, if both are 0 0, and so it must be selected as port A, and if this one is 0 1, then this is port B, and if it is 1 0, then port C, and it is 1 1, then control word register address. So initially take these 2 values as 0 0, and other values are A2, A3, A4, A5, A6 up to this one, all these are 0, because here inverter is connected. Okay, so initially it is 0, then when it is inverted it goes 1 over there. Okay, so that's why initially all these are 0 0 0 0 0. Only there is no inverter is connected with A7 line, that's why it is a direct line which is always high. So high means logic 1. So 1 should be here. And how can you find out the port addresses? In this way, take 4 binary values. 1000 means 8, and 0000 means 0, 80. That is the port A address. Okay, so what will be the port B address? The remaining portion will be same for all, only changes will be here for these two address lines, like 01. Okay, so 1000 means 8, 0001 means 181. That is the port address of port B address. Then 82 will be port C address, and 83 will be control word register address. So in this way, we have to find out the port addresses using the configuration. Then what you need to do, calculate the control word for each means for each condition. Like, what are the conditions? Now to set PC7, to set PC7, to set bit PC7, what will be the control word? Find out using that control word format, using this format. If you want to set PC7, what will be the control word? Find out and tell me now. তো যদি PC7 বিটকে সেট করতে হয়, আমার একটা কন্ট্রোল ওয়ার্ড লাগবে। যদি PC7 বিটকে রিসেট করতে হয়, আমাকে আরেকটা অন্য কন্ট্রোল ওয়ার্ড লাগবে। দ্য সেম ওয়ে PC3 কে যদি আমাকে সেট করতে হয়, I need another control word. If we want to reset PC3 bit, again I need separate control word. Is it clear?
Yes, sir.
So now tell me how many control words are to be calculated.
4, sir.
4. Okay. Now calculate the first control word to set PC7 and tell me what will be the control word to set PC7 bit. What will be the control word?
1001.
This is the BSR mode control word format. Now from this format, you have to calculate the first control word to set PC7 bit. What will be the status of each bit to set PC7? What will be the control word? Anyone?
1001.
1001 কোথায় 1 হবে?
D1, D2, D1, 0, and D1.
শুনতে পাচ্ছি না, ক্লিয়ার আসছে না। What will be the D0 bit?
1, sir.
What will be the bits of D1, D2, D3?
1.
Sir, 0, 0, 0, 1. D1 will be 1 and others will be 0.
Why?
Sir, PC7 1.
Can you see that? This one, what I have told you?
Oh, sorry, sir. 1, 1, 1, 1.
So what will be the status of D1, D2, D3?
111.
111.
111. Good. And what will be the status of D4, D5, D6, D7?
0.
Konta 0.
Before is
কিছু বুঝতে পারলাম না, তোমার কথা বোঝা যাচ্ছে না। What will be the status of D4, D5, D6, D7?
Sir, D4 don't care, D5 don't care, D6
Means don't care
don't
means
care.
what? 0 or
either
1?
0, either 0 or 1.
But I have told you that if it is don't care, always these are 0. These are 0.
Oh.
Don't need to consider
Yes.
it as 1. Okay.
Okay. The
So
D4
0.
0, D5 0, D6 0, and D7 will
0.
be 0.
Okay. Now
Yes.
tell me in this answer in hexadecimal 8-bit number. What will be the control word?
Sir,
0,
Sir,
0, 0, 0, 1,
0F,
1, 1.
0F, 0F.
Good. 0F. Okay. Now in the same way, to find out the reset bit PC7, what will be the control?
Sir, 0E.
0E. Good. And in the same way, to set PC3 bit, what will be the control word?
Sir, 0 3.
No.
Oh, PC3.
PC3 bit. To set PC3 bit.
Sir, PC3. Then 0 1 1 0. No, sorry, 0 1 1 1. So 0 7. 0 7.
Good. 0 7. And to reset PC3 bit, what will be the control word?
Sir, 0 6.
0 6. Good. Okay. So these are your control words. 0F to set PC7 bit, 0E to reset PC7 bit, 07 to set PC3 bit, and to reset PC3 bit, this will be 06. Okay. So what will be the program? Program will be this one, MVIA, comma 0F. Why? Because 0F is the control word. So every time we need to transfer the control word into control register address. So what is the control word register address? 83. So every control word must be written inside this control word register address. So this is IO mapped IO technique. So only in and out instruction will be used to process this. Okay, no STA LDA related instruction or memory related instruction will be used here. So only input and output related instruction, in and out. That's why first load it into accumulator 0F to set bit PC7 bit. Then from accumulator it goes to the 83 address, which is the address of control word register. So first control word will be sent to the control word register address. Now PC7 bit is set. Now to set PC3 bit, the control word was 07 to set PC3 bit. So send it to the first, load it into accumulator, then send it to that address, control word register address, which is the 83. So PC3 bit is set. So now PC7 and PC3, these two bits are set. Next is to call a delay program for 10 millisecond. So assume here that a 10 millisecond delay program is there. So after 10 millisecond, what happened? The bits which was set, that will be reset now. And to reset them one by one, so what is set last? PC3. So you need to reset it first. So that's why MVI A, 06 is there. So 06 is first loaded into the accumulator, and from accumulator it goes to the control word register address to reset PC3 bit. And in the same way, to reset PC7 bit, the control word must be sent to this control register address, so it will be reset PC7 bit. Okay, and the last instruction will be RET, return, because this program is your sub program. So there must be one main program from where one call instruction is executed and it executes this subroutine. So when this subroutine is completed, you have to return to the main program. And if you want to return to your main program, then RET must be used. So from main program, call instruction was executed, and after calling this subroutine, the subroutine will be executed, and when it is completed, it must be returned to the main program, so that the rest of the instructions in your main program will be executed till the last. Okay, so it is a subroutine. That's why for every subroutine, the last instruction will be RET. Okay, for every subroutine, the last instruction will be RET, and for every main program, the last instruction will be HLT, halt. Okay, I repeat, this is very important. For main program, the last instruction should be always HLT, halt, and for subroutine, the last instruction will be RET, return. Okay, so this is BSR mode control word.